right. Hello, everybody. How are you doing? Yes, headphones on, silent session. This is fun. There are volume knobs if you can't hear me okay. You just have to tap it a few times if you want the volume up or volume down. I just want to start by welcoming you to this session. It's developing an autonomous framework with Security Lake and Torc Robotics. Torc Robotics is a customer of Security Lake and a client of AWS, and they'll be talking about their use case in a little bit. We have 4 speakers today. My name's Matt. I'm a worldwide security specialist for detection and response services here at AWS. It includes Security Lake, Guard Duty, Security Hub, Inspector, Macy, and Detective. And customers orchestrate those services together to improve their overall security posture. I'm joined by another Amazonian, Ross, and 2 customer co-presenters today. So I'm just going to give an overview of some of the security data lake challenges and managing pipelines, and kind of like a story about what that looks like today for many of our AWS customers. And then I'll talk through how our customers have solved that and some of the services they used to make that much easier. We will have a live demo, fingers crossed, a live demo. And then Torc Robotics will come up and talk a little bit about their integration with Security Lake and how they've implemented Datadog as an investigation and discovery tool on top of their central logging. So, collecting security data at scale is very, very difficult. There's multiple disparate logging options today. Those logs go into individual S3 buckets. They're often inconsistently formatted, and this is all just at the data layer. We have account fluctuations, so you may need to add a new account to an organization or a resource that gets spun up to support a peak demand or an elastic workload. If you have existing logging capabilities, you need to maybe kick off a custom Lambda function to create a new partition or enable logging for that new account or resource. And that requires custom code, management of that code, and ongoing overhead. Lifecycle and access policy. You probably have some requirements for long-term log retention to meet compliance use cases. This is 1 year, 7 years, depending on the nature of the data. So managing who has access to what data and how long you store it for, and the temperature of the data, which is like, a standard class or a Glacier Deep archive. Basically, the less and less you use data, you would want to make it colder and colder. And transitioning that data in a lifecycle policy that's easy is something that actually the Security Lake console can help support. And then, of course, we want to derive value from this data. So this is like the analytics layer. So I'll talk really about like 2 layers. The most foundational layer is the data layer, the log aggregation, the finding collection, the optimization and consistency across multiple sources. And then the second layer is going to be the analytics layer, actually getting any value from those logs. And what I've found is that the security persona, we're at a security conference, right? Welcome to Inforce. The security persona actually, over time, the dichotomy of the role has slightly changed, where they were a security team responsible really for a lot of data and custom pipelines and custom code to get data from sources and destinations and to be able to investigate issues easily. Now, many, many, many customers have wanted to stop managing pipelines and stop managing their custom application code or their custom pipeline code, while still being able to derive valuable insights, which has actually made the security persona have more of a vested interest in the analytics services that they're applying to their security data, whether that be building dashboards or visualizations, doing some discovery or alerting. An example is searching an IP address across all firewall logs. This is something that a security resource would be trying to do, but with all of this disparate data across multiple sources and vendors and inconsistent formats, it turns out to be quite a hard problem to solve. And one of the things that makes it a little easier to do this is having all your data in a consistent schema. So AWS and a coalition of 18 other businesses partnered together to launch the Open Cybersecurity Schema Framework. Simply put, it's a template for security data. And it's organized in a way through event classes. And now what this means is there are several categories of source types that are all classified with the same indicator. For example, all your network activity in OCSF goes into the event class that starts with 4,000 something. And what this helps is when we're downstream doing an investigation in some vector-based, indexed analytics tool, I can actually wildcard, or I can say, I want to search across all my data in the event class that starts with 4. And what this would allow you to do is to find that IP address that's not just in WAF logs, or Web Application Firewall with AWS, but my Palo Alto network firewall logs, my Cisco firewall logs, and I can search that single IP address across anything that's in event class number 4, because it's in a consistent schema. So this is an open source community framework. We have over 200 participating organizations. And what I really love about this is when we first launched it, we co-launched it with Splunk and with the launch of the Security Lake service itself. And a lot of people would think that it was really just a schema for Security Lake, but it's much more than that. And now, actually, I'm hearing more and more customers that first hear about OCSF before the Security Data Lake service that AWS offers. And that's exactly the community that we're trying to help thrive. And we talked a bit about Security Lake. Security Lake is the place to centralize all your logs and findings that have security-related relevancy. And what we've done is we've made it much easier to collect these logs at scale. And one of the challenges, for example, would be cross-account and cross-region collection. This is not just a technology problem, but it's just a fundamentally difficult thing to do. Security Lake helps collect logs across all resources, all accounts, and all regions in just a couple clicks. And it's actually built with some new features and capabilities that make this feasible. And the way that it works is it actually goes into the backplane and collects the logs from the resources themselves. It doesn't actually look at what you've got configured already in VPC flow logs or CloudTrail management events. It goes to the resource directly and gathers a duplicative source of log streams, which would make your existing technology, you would have to find ways to basically transition to the new source that Security Lake has created. But again, it manages it's a fully managed security data lake that exists in your AWS account. And the shift here is first, we write data to S3 using Security Lake and then subscribe it elsewhere outside of our account. Rather than having a Kinesis Firehose stream data to another location, and then when we're done doing correlation, detection, visualization, replicating back to S3 later. So it just changes the flow. And really what it's doing is it's a source and subscriber model. So this is just the foundation, the conceptual foundation of Amazon Security Lake. Is there's source data that comes in. We've made it much easier to collect AWS-related sources, but you can also bring your SaaS application logs. I see time and time again, people will have log generation prioritized on their IT roadmap. But when is it going to be the most important thing to do? To write Okta log, to have your IT team design a pipeline to write Okta logs. It just never surfaces to be the first priority. So you can bring in your SaaS application logs with App Fabric, the first AWS native service to support OCSF by default. There's AWS security findings and third-party findings, which the easiest way to get them in is actually through Security Hub as like a finding aggregator. Security Hub can bring in multi-region, multi-account findings into a single pane of glass and easily share those with Security Lake in a consistent format. Then there's partner data, which I'll talk a little bit more on the next two slides, and custom data. There's a feature of Security Lake called custom source, but really what it allows you to do is collect data from you can bring any data to Security Lake as long as it's in an OCSF schema. So custom source is just anything that's non-AWS. And bringing custom source data is will not increase your Security Lake bill at all. It's intended to make it easier to bring non-AWS data to S3, and we've made that a cost-effective option. Security Lake then orchestrates several underlying AWS services on your behalf in your account. This includes creating S3 buckets, setting up SQS feeds or SNS topics. It orchestrates glue tables and schemas, and it builds out all the definitions and the underlying infrastructure needed to perform security analytics much faster. And this is it's all consistent. All the prefixes in S3 are all partitioned and consistent. It's compressing data for you. It's doing Apache Parquet conversion. And it actually just takes away a lot of the undifferentiated heavy lifting from managing a central logging pipeline. So that's the Security Lake orchestration. And then there's subscribers. So a subscriber is somebody who receives data from the lake. And when we first launched Security Lake, it was really about providing optionality for your downstream security analytics tools. And this means you could set up Splunk as a subscriber. Torc will talk about how they've subscribed Datadog to the Security Lake data. We also have AWS native security analytics services like QuickSight, which Ross will demo, or OpenSearch. But it allows you to take advantage of the tools that you're used to, your teams are used to do investigations or build dashboards or alerts on top of data that's in a data lake. So talking about partners, what does it mean to be a Security Lake partner? So not only did partners like Datadog and now now several others have gone through two steps. They, one, have agreed to support OCSF, and two, have gone through a due diligence with Security Lake to prove that they can add value on top of the data that they're either sending or receiving from the lake. So this is like an upper echelon of the OCSF part of an OCSF community. Is now they can also be Security Lake partners. There's native AWS sources, and I know that these are like logos on the screen. There is more context about the individual products that each one has supported when streaming data to Security Lake, and there's a page that shows all the products. And every time I show this, someone from our team, our partner development manager, will say, there's a new version of that slide. And it's because there's new partners getting added all the time, or new log sources supported by Security Lake, which is actually a great problem to have. So these are the data sources, and then there's the analytics and subscriber partners. So you can actually start to analyze data. There's two categories of partner data. There's or partners on the subscriber side. There's partners that will just receive data from the lake, but then there's also managed service providers that are building out holistic solutions on top of Security Lake. You may see some from PwC and Deloitte that PwC has fusion centers, is all natively built with Security Lake in mind. So just a little journey about kind of where the evolution of Security Lake. We went into public preview in November, and we made Security Lake generally available to the public for free for 6 months. Now, during these 6 months, we ingested so much data you would need semi-trucks to move it. And what's significant about that is just the number of clicks it took for customers to do all of it in the cloud. I always like to say these logs take up physical space on Earth. So to conceptually think about the amount of volume that we ingested even during public preview was astonishing. And then we launched general availability. With GA, we also launched some new regions, and which more came in October. The best method for a global logging service or central solution for managed logging is to make sure that it's available in all regions. So that was a big focus, and expanding services to new regions is quite an undertaking from our organization. And then the next thing we did is we wanted new sources. So we needed fully managed sources, and the top two that we prioritized based on customer signal was EKS audit logs and WAF logs. We came out with a set of 6 or 7 native AWS supported services or supported sources, but we're continuing to add more and more as time goes on. Iceberg support is just it's to make it more query performance, so your searches will return values much faster and more efficiently. And infrastructure as code. I see more and more people want to move away from actually logging into the console and managing things in the service in the AWS management console itself. So having CloudFormation support was big. And here we are at Reinforce. It's great to see, I've been on the team with Ross since the very beginning. And, I remember migrating from beta to GA and helping customers through that. And now we're really starting to see some customer success stories come out on the true value of a fully managed security data lake and fully managed logging services that are in your AWS account. So this is just like a general topic of streamlining security operations. Of course, the services that we talk about will augment your ability to do this, but this is kind of the next iteration or the next generation of where the destination that I see security operations teams moving to. And it is kind of like a left to right, really about like only collecting the data we need for analytics or retaining the data we need for analytics. So like there's a bunch of, I don't want to say useless data, but there's a bunch of event types that we may not correlate or we may not alert on, like KMS encrypt, decrypt keys make up almost half the volumes of data events in some cases. And there's no analytics or value or insights that we're really going to get from them. So if we can drop those events, our customers will save a lot of money on storage and any replication or data transfer out. Doing compression, so making them smaller, doing a conversion into Apache Parquet gzip or any logical compression that we can apply. Security Lake will compress data from raw volume to over 90%. So it'll be less than 10% of the original raw log volume size. And then of course you want to make it colder and colder as you need it less and less. Everything will land in standard by default. This is just a good practice to have. Maybe transition to intelligent tiering, which will automatically adjust the object retention so you can get access as you need it. But if you have long-term retention, several years worth of data, and you don't need to search it regularly, you can make it colder. Then only send data you need to the subscribers who need them. And Security Lake actually enables you to filter the subscriber feeds by data source. But this is just, data movement is like a physics challenge. Like we have to physically move data and it has costs associated with it. So an actual way to save money is to just move less data. And then you can enrich or drop events. We talked about that in the ingress filtering. So like this is on the egress side. If you're egressing data into another environment, if you're reducing the number of events or the volume there, you also like reduce the any ingestion fees, outside of AWS. Federated search is actually like a new topic that's been coming up more and more, is broadening the aperture of searching capabilities to any data that's in the S3 buckets themselves without the needing to streamline or pipe it into the analytics service itself. And we're seeing a lot more support for this lately, especially with Security Lake and S3, and having it in a consistent schema like OCSF actually makes federated search much better. But there's, IBM QRadar, Cribble Search, Splunk Federated Search are now, in support of the Security Lake data. And then, deduplicating retention, like long-term retention in S3, the more and more we can store in S3, the more efficient our storage solution will be, or the less costly it would be. It's efficiently scalable and resilient storage solution that is really a good place to call home for many of our long-term retention use cases. So, next, we'll have a live demo.
Okay, cool. Can everybody hear me? Okay, cool. Thank you very much, Matt. I don't need that. Okay. Again, I'm Ross Warren. I'm the product SA on the Security Lake team. And let's hit the button and get the demo going. All right. So Matt and I, as he hinted, we've been working together for quite a long time. We do a lot of customer calls together. We've been on stage a bunch of times. And I've sat through many times of him writing SQL queries. You know how fun that is? He loves doing it, but I've sat through many, many times of him writing queries and showing the customer the value that Security Lake is giving them by building up Athena tables anytime any of those custom logs come in, anytime any of those AWS sources come in. We now have Athena and Glue tables ready for the customer immediately to use. You don't have to go think about glue crawlers or normalization or SQL. None of that has to be configured by the customer. And so I was actually amazed. A couple weeks ago, Matt goes, well, Ross, It's not up there. So while he's doing that, what you're going to see is Matt said, well, Ross, look, I made this dashboard in QuickSight. And I took a step back. I said, Matt, you're a great SQL guy, but you made this dashboard? Yay. All right, so this dashboard looks really, really cool. It's, again, what I'm going to show you is my interpretation. Matt didn't tell me fully how he did it, but it's my interpretation using QuickSight and using QuickSight Q to actually build up a dashboard like this. Remember, SOC analysts need dashboards, CISOs need dashboards, right? Just for reporting, for us to look at what looks like normal, maybe look at spikes and things. So we're going to kind of walk through what does that mean and how to build this with, let's say, QuickSight Q or generative AI. I'm going to show you a little bit behind the scenes first before we start doing some queries. So once you're in QuickSight and once you enable Q, you need to build a topic. A topic really is a data source. Remember I talked about the Athena tables that Security Lake builds for you? You are really going to point QuickSight and Q at those tables in Security Lake. So if you can see, yep, we've got CloudTrail and we've got Security Hub topics in QuickSight Q. You enable that, you point it at your Security Lake data. It then does its thing. I'm not an expert on it, so it does its thing and will actually give you, if we take a look at one of them, come on. It then looks through the OCSF schema. Remember, all this data is normalized to OCSF, and so now I have my friendly names, and I can actually build up some synonyms, maybe actor or account ID you kind of want to use as a synonym as you're maybe doing some of your queries. But I thought what was really cool, normally there's a lot more there. Oh, here, sorry. When it's done building that topic, it gives me a list of questions that you could ask of the data that would then start building up visuals, or maybe that the analyst would actually want to do, right? I've done no work besides telling it where the Security Lake data is. It's gone and chunked through the data and been able to give me all of this. And now let's go back to the dashboard. And all right, we're going to start thinking about building that dashboard in a minute and a half. Very, very quickly. I've got a whole bunch of questions up there, and I can, if you look, you can see it tells me which ones are AI generated, or as users are using the system, and if a question gives me a good answer, I'm going to say verified. If it's not going to give me a good answer, don't say verified. It won't use it as part of its learning model. And so we're going to click through. And I did what are the most common activities that users engage in. Not really a wonderful thing, but I'm going to sort of walk you through what's going on here. Whole bunch of read activities. Remember, we're looking at CloudTrail, which is API activity. It's normalized into OCSF in my Security Lake. If I want to start building up a dashboard, I'm going to start looking for the visuals I want on that dashboard. I'm not writing any queries. I'm just doing some natural processing here. Sorry, natural language. And I'm picking things to add to my pin board. Let's call it Pinterest. As I did this in my previous demo, I built up a bunch of visuals that I may want to use later on in building up that dashboard. And the next step becomes really, you start to share them. You start to share them out. Come on, highlight. Oops. So once I get them to my pin board, I copy the link to the dashboard, and then I go make a new dashboard, and I can start very easily adding those visuals to that dashboard. And, hopefully quickly over time, you're going to get to what Matt built here that's got CloudTrail. I've got Security Hub, and he surprised me the other day with this really cool Cloud Summary one that is bringing a lot of data across multiple different data sources to a visualization. That was really quick. I have some other demo items to do, but I'm really, really excited for you guys to hear what Torc has had to do with Security Lake and streamlining their operations. And does it go up? Yep.
Thanks, sir. Okay. All right. Thank you, Ross. Hi, everybody. I am Jason Fox. I am an engineering manager at Torc Robotics. So I run a team of cloud engineers responsible for AWS infrastructure and security for Torc, for all of our engineering. A little bit about Torc. Torc is an independent subsidiary of Daimler Truck. So Daimler Truck manufactures the Freightliner platform of heavy trucks. They're everywhere on the roads in the U.S. if you've ever been. Like 40% market share. Torc has a long history in autonomy. So we have pretty deep roots into it all the way back to 2007. So in 2007, Torc participated in something called the DARPA Urban Challenge, which was a competition to develop vehicles that could navigate intersections, obstacles, park, all that kind of stuff. So we placed in that competition, which was good. That was 2007, so the math was a long time ago. The next step for us, so we took a slightly different path than a lot of our competitors, and we went to doing self-driving vehicles, autonomous vehicles for the mining industry, the construction industry, and the military, so defense industry. The unifying part of all of that was safety and saving lives. So it's a big part of Torc. It's a big part of everything we do. All of our employee badges say saving lives on them. It's critical to our business and the stuff we're doing now. We are laser focused right now on commercializing level 4 autonomous trucks for long haul trucking. So that's what we're doing now. And so next, a little bit about my team and how Torc approaches the cloud. So Torc's been a customer for AWS for a long time. We have a very large organization within AWS, hundreds of accounts across bunches of regions. We have production and development workloads across EC2 and S3 and Lambda and managed services. We use all kinds of AWS. We're doing accelerated computing. We're doing machine learning, as you can imagine. We're doing lots of Lambda, lots of APIs, web applications, you name it, all the stuff in between. A big part of how we operate at Torc, and one of the big things that I do on my team, is empowering our engineers to be as fast as they possibly can. We're in an interesting business, and so we need our engineers to be as flexible and agile as they can be to use whatever services in the cloud they need to reach their product development goals. We offer a pretty permissive environment to do that, so we're very flexible. While my team owns the AWS organization, we're very flexible and permissive with how our engineering teams use AWS. And we do that largely through a combination of guardrails. So we have operational and security guardrails. We have pervasive automation throughout the whole system. And we do a lot around well-architected pattern usage throughout the organization. Internally at Torc, my team is called the Cloud Automation Team, and that is entirely intentional. So our team has automation at its heart. That's all we do. It's a relatively small team compared to the size of Torc and especially our engineering technology group. And so like everything we do is automated and at scale, and we have to keep it that way. But in the end, our goal, again, is to make the development teams as fast and as flexible and agile as possible while keeping them safe and secure in an AWS environment we provide. So coming from all those principles, so all that background, we had a few challenges when we were setting up a security and observability practice at Torc. We struggled at some, this has been a few years in the making, right? And so we struggled around collecting data, so collecting log sources and signal aggregation and anything across all of these accounts, all these regions, all these services, so everything that we do. And it's critical that we're able to collect it and know about it no matter where it is, in the world, in AWS, or wherever. The next step then, of course, is we have to do investigations. So we collect all that data. We have to be able to do investigations, and that's operational investigations. That's security investigations around, so operational around does it work, is what's not working. Security around, we get events, we get incidents that we have to respond to. And then financial ones as well. So we do respond as similarly to and have to do investigations across all this data to figure out sort of are we using the cloud most efficiently. And a big deal is we have to be able to collect all of this data, no matter where it is, and no matter which service our engineering teams are using. And like I said, they don't have to come to us and ask permission to use services. So we have to be ready to collect the data when it comes online. And so that's the big part of it. That's in order to tie it all together is the last part. So it's custom integrations across all these log sources. So my team has built hundreds of integrations and deployed hundreds of integrations throughout AWS and otherwise to collect data, to aggregate logs, to enrich, all of that stuff. So we have built all of this custom plumbing, and we're responsible for maintaining it. So we have some business drivers too, right? So we have, those are largely technical problems. There are a lot of business drivers that the company wants us to do. It has, stuff for us to do in order to make sense of this practice we're building or have built. One of those is agile development. I'm not going to repeat it again. I say it all the time. Like, our developers have to be fast. Like, that is critical to our business. We're in a very competitive industry and something that hasn't been done before. But you remember early on I said safety. So safety is critical to Torc. And so being able to integrate both the agile development speed with security in a way where these engineering teams don't necessarily have to worry about every little bit, and we can, as the watchers of the systems, can handle that. And then, as you might imagine, being in the industry we generate tons of IP. So lots of IP, lots of valuable data that we have to protect. The company needs us to protect that. We use AWS, so the company needs us to protect all of that data. And lastly, my team is an engineering team. So we are an engineering team like any other engineering team. We are not an IT organization. And so the company needs us to provide differentiating services to Torc, not plumbing. So they don't want us spending a bunch of time writing log collection code. They want us building detection routines and remediation stuff that's specific to the way Torc works in order to make sure everybody's safe, right? So we're not just collecting logs, we're actually doing something with them. So we selected Security Lake. I hope it's no surprise. We are using Security Lake now. But we had built a bunch of this stuff before. So why did we switch? Why did we move to Security Lake? We built up quite a library, like I've mentioned. Tons of code, lots of stuff to maintain, lots of log collection, lots of aggregation work, enrichment, all that stuff. And we had to build, a big part of it was we had to keep an eye on and build new integrations as services came on. So it was a load on my team that we constantly had to stay ahead of our engineering teams and do these integrations. So in November of 2022, when Security Lake was announced, Matt, who you'll meet here in a moment, Matt and I sat down and did a quick a quick technical review of what Security Lake provided, and then what we had built. So like all the stuff we had built, and see if there was overlap. It turns out there was a ton. So there was a lot of overlap between what we were doing and what we could get from this managed service. And that meant we get to do, I think Matt's probably going to mention it too because it's his favorite as well, my favorite thing, which is delete code, delete stuff, delete it. So we got to get rid of stuff that my team had to maintain and use a managed service so we could get onto the stuff that actually mattered for our business. So the Security Lake automates that, right? So that's the Security Lake is the managed service for all of the stuff we were doing manually, and I think that's really a big reason we went with it. Lastly, too, we have a very deep partnership with Datadog. So they are our observability and security response platform for Torc, and we've used them forever, right? And so they adopted Security Lake or integrated with Security Lake from day one, so from the minute it was announced. And that was a huge deal to us, right? That was a big advantage to us because gone were the days where my team had to go, okay, so now we got this, how do we get it to Datadog? How do we send this to Datadog? Like what kind of things do we have to build? It's just simple. Like if it's in the lake, then it's in Datadog, and we don't have to worry about any of the plumbing or any of the extra stuff that goes along with that. And I'm going to bring Matt up to talk about a little bit more about the technical part of this integration.
Well, that was a little bit interesting. Thanks, Jason, for the introduction. I'm the other Matt. I'm glad that you can hear me now. I'm the staff engineer from Torc Robotics. Continuing on the benefits we received from Security Lake, multiple parties are getting what they need. Our engineering teams don't have to be burdened with log collection and managing those tools. And our security teams get the benefit of automated account enrollment, streamlined aggregation, and the capability of multiple subscribers. So powered by OCSF, we can consume CloudTrail logs into Datadog. This is the Datadog Investigator, and it allows us to see IAM role activity and its interaction with different AWS services. We could click on one of the boxes within this workflow and be able to see all the CloudTrail logs, and all of this is generated automatically for us. So let's give you a look at the before and after with Security Lake in the Torc environment. So on the left, we have our AWS organization, hundreds of accounts across multiple regions. Each account would have different types of collectors to collect different types of logs. So it could be a CloudTrail, could be Route 53, could be WAF. They're all forwarding their logs to Datadog for ingestion and for evaluation. We're also sending in GitHub and Okta logs for auditing. On the right, in our post-Security Lake world that's continuing to evolve, again, many AWS accounts, across many regions. And we still have all those different sources to collect, but now Amazon Security Lake is collecting those for us automatically in a centralized S3 bucket in a central region, and then forwarding those on to Datadog for us. We have less custom management and automatic account enrollment, so you can focus on actual security issues and not the effort of actually collecting the logs. So let's recap our challenges before Security Lake. So collecting all the logs at scale is not fun. As Jason mentioned, he has a small team. We need to do more with less. Digging into the root causes of security events across multiple accounts, definitely not ideal, and it was slow. So we needed the capability to answer questions and solve problems quickly. Collecting CloudTrail, Route 53, WAF logs from across the organization was not seamless. We had to own, maintain, and monitor those logging pipelines. So how did Security Lake make our lives better? Well, the configuration and management was quick and painless. In one sitting, we were able to get Security Lake forwarding our CloudTrail, Route 53, and Security Hub logs to all of our AWS accounts into Datadog. First try, it was during the beta. It just worked. I actually thought I did it wrong. So also, as new log sources became available, we've been quick to adopt those. So on May 22nd, Amazon released WAF logs for Security Lake. Within an hour, we were collecting all of those logs from across our organization and sending those into Datadog. Let's see here. One of the other additional benefits was being able to investigate faster. So, short story, we had received a cost anomaly detection alarm for Lambda spend for one of our development accounts. About $6,000, not completely, out of this world, but it was still an amount that we wanted to investigate. So I started looking within Datadog at for that specific development account, looking for high invocations, high durations for Lambdas, and I did find some. I happened to go over into the the AWS console for that account, but those Lambdas weren't there. I went back to Datadog and looked at the CloudTrail logs, and I was able to see that those Lambdas were deleted. So they were deleted by automation, which was, made me feel a little bit better. But in this case, an engineer had deployed several Lambdas, ran up the bill, evaluating, some data, executing some workloads, and then removed them through automation. Again, not catastrophic, but from our perspective, the investigation was simpler, faster, and repeatable, with Amazon Security Lake collecting all of those logs for us and then using Datadog to help investigate. Lastly, as Jason mentioned, Amazon Security Lake allows us to delete some of that custom tooling that we had to deploy before Security Lake was in our lives. We were able to put together pull requests, delete some of that custom code, and deleting dead code is one of our favorite things to do. So now that we're a year and a half into our implementation of Security Lake, we've learned a few things, and none of it's been painful. There was a slight hiccup during the transition from beta to GA, where some of the original source names were changed, but that was a quick fix. We ran into an issue where one of the newly released log sources wasn't supported by Datadog. It's not really an Amazon problem, but we worked with Datadog, and it was fixed very quickly. This is an issue to be aware of when integrating Security Lake with a third-party subscriber, even if it's not Datadog. Also, not too long after GA, we had a brief window where new account automatic enrollments were missed, just a few. We worked with support, gave it the old try now, and it was resolved. We haven't seen it since. That was probably right after GA, no issues. Lastly, speaking about log aggregation across many services and hundreds of accounts, this is not a real-time solution, so you should take the steps to employ other surveillance systems and tooling for remediation or prevention. Looking forward, how does Torc improve its posture on security response with Amazon Security Lake? We're going to bring in more logs. It's always more logs. We're going to bring in some third-party SaaS logs through AWS App Fabric, which is another service. We want to do remediation in a more automatic fashion. This could be done with Datadog workflows or other tooling like Cloud Custodian, which we both use. We use both of those. It works great. We want to do more enrichment. If you've operated an AWS security program at scale, you're probably all too familiar with false positives, maybe from a Macy or a guard duty. Jason's team spends a good amount of time, trying to remediate some of those false positives. This is possibly, a Gen AI scenario. Maybe it could help. But in some cases, if you're removing an S3 bucket, this involves removing, some of the public access policies. Macy doesn't like this, and send some alerts. So this is a scenario where some enrichment and adding some additional signals could help potentially remove some of those false positives. Finally, as a significant consumer of managed services, we're eagerly awaiting the capability to consume more AWS sources. So we're desperately waiting for API Gateway. Hopefully Matt's going to be able to deliver that for us in the near future. Amazon Security Lake is helping Torc lower the burden for log aggregation and helping us move faster, helping our security engineers investigate incidents and security events as quickly as possible. Thank you very much. I'm going to pass it back to Matt to wrap it up.
Thanks. Hopefully you can hear me. It's pretty rare that the two technical difficulties in a session and neither one of them was the demo, so I'll take that as a thumbs up. I do have some recommended sessions. I just want to thank you for your time and thank you for coming to this session. And thank you for participating in Reinforce. I think it's great to have a security-centric event. These will be smaller sessions, more hands-on with a couple of my peers on the security team. You'll probably meet Marshall, a worldwide security essay. He wrote the AWS Foundational Best Practices for Managed Security Services. So ask him all your hard questions. And Security Lake fits in a broader ecosystem, but we've been kind of painting this picture of simplified log aggregation, managed log collection, and now I think you've probably seen the two different layers of data layer, observability layer, analytics layer, right? There's the managed log collection, getting everything in a consistent schema in a single place, and then sharing that or performing some analytics and some search, like augmenting that with some search capabilities. And there's definitely a broad category of just easily investigating specific issues without the need to do massive data pipelines and transitions into outside of your AWS account. So, again, thank you for joining. If you have any questions, we'll be up here, and I appreciate the time.